I'm going to use his notation. Hang on. Before I show you that, I forgot. That's supposed to be straight. Again, the area of interest is going to be between this interval. Now, very nicely, we start at the beginning, we just have a nice interval. Eventually, like in Calc 3, even parts of 2, it's going to get a little bit more complicated. So when we have the area that we're interested in, and we do break it up into rectangles, what we're going to do is we're going to say, let's use orange. As we break it up into rectangles, be it bigger ones, smaller ones, whatever. If this is x of 1, then we have x of 2 next to it, x of 3. A becomes x naught. B becomes x of n plus 1. And, I'm sorry, n. So it's the 2 endpoints. And I deliberately didn't fill out the rest of them because I want to leave it kind of generic. Now the distance between them is delta x, and once again, delta x is here. Define each of these points. Yeah.
You're saying b is equal to x sub n because you're relating it to the actual n value, right, of delta x?
Say it again.
B being x sub n, you're relating it to the value of n.
If I kept counting these, x of 1, x of 2, x of 3, it would go up to, so in this case, in the last case, x of n was 1.
Okay.
So it's always going to be that endpoint.
Okay.
These are called the node points. You'll hear me say that word. You don't have to use it or know that. Different books call different things. I don't know what this book calls. Sample points, whatever. And the way that this works is, this is how I get the next piece. So try to follow along. If I is 0, then x of 0 is a, which we know it is.
I is
If I want
0.
to get to the next one, I have to add a delta x, right? So I'm going to start at a, and I'm going to add a delta x. That'll give me my x of 1. I need to go another x, delta x. So actually from A I've gone 2 delta x's to get there. So I would be 2 in that case. This will get you all the node points that we're interested in. That'll be important here in a minute. And yes, in between, I'm running out of colors here, let's see.
What?
I mean, ones that are different enough. No. So in between here, we're going to write it with this notation. So our actual points that we're going to be using are actually going to be between 2 points. Yes?
Can x be a complex number?
No. Not for now. No, for sure. In fact,
Does it literally
we're not
say
doing
x
any
star?
complex numbers. I do something with you guys, one of the last things in my Calc 2 class, but other than that, we're not going to do that at all. So we're talking about these values in between. So any x value between there is what we're going to be using. So the area is limit as n goes to infinity. Don't they have a summation? This has a fancy name. It's called a Riemann sum. Oh. Started at 1, sorry. We're going to have to manage this, actually. And this is an introduction to the main thing that we're doing today. So the height of the rectangle is going to be the, based on this here. This isn't going to matter in a bit. Do you remember when you first learned how to do a derivative? And we did it the long way. Remember all that work it was? And I abused you and said there's an easier way later, but you got to earn it type thing. That's what we're doing today.
Excellent.
So today's going to suck. Yeah. A couple things to keep in mind. I know the lighting over here is pretty bad. Constant is n times constant. That's n times. We will definitely need to know these. I need to double check myself on that one. Yep. I'm going to derive the second one there. Before I can tell my story about Carl Friedrich Gauss. So he was in grade school. Let me go finish copying that.
Third one is I and B, or is it I squared?
I cubed. The last one, oh, the third one is I squared. The last one is I to the third power. This is going to be important here in a minute. It's just any place between your nodes. Could be the endpoints, or maybe not.
Yeah, and the eyes aren't imaginary numbers. Has nothing to do with
I has nothing to do with the measurement, it's a counting number at this point. Yeah. Your book uses, I used to teach this using K, but the book uses I. I'm trying to match him up. Okay, so let me tell you about Carl Friedrich Gauss. When he was in grade school, his teacher told the class, he said, I want you to add up 1 plus 2 plus 3 plus 4 all the way up to 10. A few seconds later, he came up to his teacher with the answer. The teacher said he was cheating. He said, I want you to go out in the hall, and I want you to add up 1 plus 2 plus 3 all the way up to 100. So he came back a few minutes later with the answer. Teacher got all angry again. Teacher went home, spent a lot of time, and found out that he actually had the correct answer. Here's what he did. He said, this is what I was asked to do. He didn't do the ends, of course, but with the numbers. And then I'm going to do it again. And he rewrote it. Notice I now have twice the amount if I add them up. Notice, as I go to add them up, I get n plus 1. When I add those two up, I get n plus 1. When I add those two up, I get n plus 1. This is grade school. This person came up with this. And how many of them do I have? I have n of them, right? So if I add them all up, I'm going to have n times n plus 1. But notice I added double. It's too big. So I had to cut it in half. Right? Because I added them up twice. So to compensate, I got to cut it in half. So there's where the formula comes from.
Wow.
How did you figure it out? he was off the charts, incredible. He was helping his dad, like when he was like 5 or 6 years old, with his dad's ran a business. He was helping with the books. He was correcting his dad's mistakes. Yeah. Gauss is one of the few names. Usually, when a mathematician gets famous for a theorem or something, it's in a specific field. Gauss is one of the few mathematicians where every branch of mathematics that I ran across, his name was there.
Wow.
So he's just a giant. He's in statistics. He came up with the bell curve equation. Yeah, in fact, back when Germany used the Deutschmark as currency, on the 10-mark bill, it was his picture with the formula and everything like that. So he was huge. He was one of those child prodigies that was amazing, but he was a total jerk. Like, people would come up with theories that would disagree with his or something, and then publicly he would just destroy them. I mean, it was a total problem. But, yeah, he came up with that. Anyway, I'm not going to derive the other ones for right now. This one you can kind of see. The summation notation means that I'm adding up. You guys have seen this before, right?
Don't be scared.
Yeah, if you're reading it out for, I'll show you this. Okay, so what this says is it says I'm going to start out and I'm going to take C, and then I'm going to increase I, which doesn't affect this. Then I'm going to add another C, then I'm going to add another C. How many times?
N times.
N times. That's why it's N times C. This one says start with 1 plus up at 1 to 2 plus up at 1 to 3 plus up at 1 to 4 and so on. So that's how this relates to this. We okay? All right. So we're going to do this. Yeah, Gauss is all over physics as well. In fact, if those of you who take a, what do you call it here, 3B eventually, that's electromagnetism, his name is all over that stuff. Yeah. The way he approached physics was very different. So I'm going to leave these up because we're going to use these. And what I want to do is introduce, actually before I get there, I'm going to introduce notation.